Okay, we're going to pick up where we left off on 8.3. So we're looking at the example 3, determine the radius of a circle of a circular pizza with each of the following areas. So note, the formula for area is pi r squared. So we want to find the radius. So we really want to solve for r. Okay, if this is the area, then that means 36 pi is equal to pi r squared. We want to solve for r. Okay? So to get r by itself, the first thing I can see that I can do is, how can I get rid of pi? Well, it's multiplied, so the opposite of multiplying it is dividing it. What's pi divided by pi? It's actually 1, right? So these cancel, leaving 36 equals r squared. Any thoughts about what r would have to be? Well, we could take the square root and we get 6 equals r. Now, usually it would be plus or minus. It would be both, right? But because the radius has to be positive, the radius is going to be the positive 6 inches. And the reason why it's 6 inches is because when we square it, that's how we get area. Area is always in square inches. And then, but our radius is a linear distance. So the radius of a circle looks like this. It's half the diameter. Diameter goes all the way across. Radius goes from the center out, if that looked symmetrical at all from my drawing. Okay, same thing here. This one doesn't have a pi in it. It was probably rounded off, right? So 250 equals pi r squared. First thing I'm going to do is divide by pi. Okay, now I have 250 divided by pi equals r squared. And in order to find r, I'm going to take the square root. Okay, square root of 250 divided by pi equals r. And that would be plus or minus, so the radius is... for this one, I would want to use a calculator because I don't know what 250 divided by pi is. So I'm going to do the square root. Oops, what's that? 8.9. Well, let's just show it on here how we would do it. So the square root of 250 divided by, oh, and I don't know where pi is. Oh, there it is. Shift pi. Okay, is about 8.9, right? 8.9, approximately 8.9 inches. Same thing here, 75 equals pi r squared. So divide by pi, and we have r squared equals 75 divided by pi. And then in order to get pi r by itself, we're going to take the square root. So square root of 75 divided by, shift pi, enter, 4.88, or r is approximately 4.9 centimeters. Okay, so those are examples of how we would solve for r. That's an example of when we would use the square root. Here's another really famous example of when we use the square root, is using it in the Pythagorean theorem. So the Pythagorean theorem works for right triangles. For any right triangle, the length of the three sides have the following relationships. A and B are going to be the legs. So they're the shorter sides of the triangle, and they're adjacent to the right angle, meaning they're next to. These legs form that right angle. That right angle draws an arrow to the longest side, which is C. So A and B are the legs, and the longest side is C, which is called the hypotenuse. Now, the hypotenuse could always change depending on the orientation of the triangle. So it's really important when we use this formula that we identify A and B could be interchangeable. You could easily say, that this is the same thing. This could be B and this could be A. It doesn't matter because they're just the two sides. And we just use A and B to show that they're two different sides. They don't have to be the same. Okay, so here when we set this up, we have A equals 6, B equals 8 centimeters, and then we're trying to find C. So we go 6 squared plus 8 squared equals C squared. And now, how do we get C by itself? Well, C squared is already there, but we have to go through the order of operations. So we can't add these before we square them. So we have to square them first. 36 plus 64 equals C squared. This would give us 100 equals C squared. And to find C, we would take the square root. Yes, square root, C equals 10. Now, why don't I use plus or minus 10? Why would I only choose to include the positive? Yeah, it's length. So you can't have a negative length. So C equals 10 centimeters. Okay, here, since I see the right angle is pointing to the hypotenuse, C is equal to 13, A is equal to 12. So this time, this one is a little bit more algebraic because now we have B squared. We're trying to find B. So we have A squared is 12 squared plus B squared equals 13 squared. So now we want to solve for B. So the first thing I'm going to do is square 144 plus B squared equals 169. To get B squared by itself, what do I need to do next? Yes, subtract 144 from both sides, and I get B squared equals 25, right? And then the square root of that, B equals 5. So B equals 5 feet. Okay. Here, again, I see that right angle. It's pointing to my hypotenuse. So C is 4. A is missing, and we have B is 2. So we have A squared plus 2 squared equals 4 squared. Okay. What am I going to do next? Yeah, I have to multiply 4 equals 16, right? Subtract the 4. A squared equals 12. To get A by itself, I'm going to take the square root. A is approximately, if we take the square root, clear, square root of 12. So yes, so you're right. Okay, so actually that would be equal to, you're simplifying, yes, 4 times 3, which would be 2 radical 3. Good. A equals 2 radical 3. And sometimes that's not helpful if I want to actually build the shape. I might want a decimal equivalent. So if you notice, if you take the square root, clear. If I take the square root of 12, I get, there's the exact answer. And then if I push for the decimal, 3, this is going to be around 3.5. So A is approximately 3.5 meters if I just round to 1 decimal place. Okay, so this was the word problem, and you're going to see some word problems like this on the final, well, just like at least one, and then on the final review it's a little bit different, but it's a similar concept. So we need to reach the gutters that are 20 feet high. So we're going to draw, this is our wall, up here is our gutters. They're 20 feet above the ground. Because of the location of some shrubs, okay, we need a ladder to be 4 feet away from the wall, not drawn to scale clearly, okay? So here's our ladder, okay? How tall, what's the minimum length of the ladder? So notice this forms a right triangle, our wall, so this has to be the hypotenuse C. It's going to have to be longer than 20 in order to get that distance away from the wall when we have our slant on our ladder. So we have 20 squared, because this would be A or B. This would be, if this is B, this one's A. 20 squared plus 4 squared equals C squared. So that would be the formula we would use. And now we need to solve for C, which would be the minimum height of the ladder. 400 plus 16 equals C squared. 416 equals C squared. And then to get C by itself, we will take the square root. So square root of 416 is C is approximately 20.4 feet. So our the minimum height of the, and it's always best, when you have a word problem, write it out in a sentence, okay? Sentence answers are requested and appreciated. So I'm not modeling it very well by just writing sentence, but you know what I mean. The minimum height of the ladder. It should be 20.4 feet. Yes. Oh, yeah, that's a coincidence. Total coincidence. Yeah. Is the 20.4 have to do with, yeah, we could try. That's always a really good, when you're seeing things like that, you're thinking mathematically, and then it's always a good idea if you have that sort of theory, you could do multiple problems. That's how math theorems are created. People start to see patterns and they notice them, and then they say, oh, I wonder if that works every time. Well, we'd have to do it so many different